Alright, today we are going to learn a new one for this chapter of correlation and regression. So for the part of regression, we would like to have the line of best fit. Okay, so the regression line is actually also known as the line of best fit. So when you plot your scatter diagram, as what you have done in the correlation and regression, I mean the part of correlation, when you plot, you can see that we can see the pattern between the y and x axis. Okay, and from there you can actually try to get the line of best fit. Okay, so how do we get the best line of best fit? Okay, so in this topic, we know that it is going to be a simple linear regression model, which is from the scatter diagram. From the scatter diagram, we can try to find out the line of best fit. Okay, and from the line of best fit, you can see that the line of best fit here is actually our straight line equation. Okay, so it's a straight line equation. So do you still remember your y equals to mx plus c? So this is similar to that one. It's just that we are now using y equals to a plus bx. Okay, so the gradient, if you try to understand, the slope of the line is the one which is multiplied by x, and a is what we call as the y-intercept. Okay, so we we have the formula which is y equals to a plus bx just now. Okay, so what is the formula that we have for finding a and b? Okay, before this, you know that it is supposed to be the slope of the line and the y-intercept, but we are now using the concept of the least square regression line of y on x. So therefore, right, the concept or the formula that we get here is the one that is actually trying to minimize the distance between the estimated value and the original value. Original value are all the plots, yeah. The plots are our actual values. Okay, so when we see the difference between the original value and the line, that is what we call as the difference. Okay, and we are trying to minimize the distance, okay, the square distance of the original value and the line. Okay, why do we have the square values? Because we understand that when it comes to square values, it is going to be considered to be all the positive values, right? So we are trying to find the minimum or minimize. We are trying to minimize the distance between the estimated and the actual values. Okay, so the formulas that we get for this is b equals to this one and a equals to this one, right? So after you get the value of b and a, you are going to substitute into the equation of y equals to a plus bx. Okay, the place of b and a would be replaced by the value that you get from this formula. Okay, that is how you get the equation of regression line. Okay, now we are going to move on. The next one is forecast and predict. Okay, what is the purpose of having the regression line equation? Okay, we know that equation is y equals to a plus bx just now. So if you are trying to forecast or to predict the value of y, you are to substitute the value of x that you have or you want to know. Okay, so for example, let's say you already have the equation of y equals to 2 plus 3x. Okay, y equals to 2 plus 3x. So in order for you to find what will be the y value if x is equals to 3, you just need to substitute into the formula. Okay, so in this subtopic, you are actually trying to forecast or predict the value of y given x. Okay, value of y given x. Right. Okay, so now we are trying to understand the type of forecast that we have here, which is interpolation and extrapolation. Okay, when do we say that we are doing the interpolation process? Okay, interpolation process. Okay, this is what we need to understand. Let's say our data is actually given from x1 to x7. Okay, let's say this is just the data that we have, and the range of data of x that we have is between x1 and x7. Okay, so if you are trying to find out the value of y, if you are trying to find out the value of y given x4, for example, x4, and x4 is in between the range of data that you have, x1 and x7, you are saying that it is an interpolated forecast. Okay, interpolated estimation. Okay, so when you are having interpolation, okay, what can you say? You can say that your forecast is more accurate and reliable. Okay, why is it more accurate and reliable? We can see that we are just having, or we are trying to get the value of y, which x is still in the range of our data. So that's why the forecast is more accurate and reliable. Okay, what about extrapolation? Okay, extrapolation happen when you are having your range of data is between x1 and x7. You are having the original data that you have is between x1 and x7, but you would like to know the value of y if your value of x is x9. Okay, remember our original data is between this range, but x9 is out of the range. Okay, so when it is out of the range, we say that it as the value that we get from this estimation would be an extrapolated value. Okay, so when it is an extrapolated value, the value are said to be, the forecasts are said to be less accurate and unreliable. Less accurate and unreliable. So every time you do your estimation, every time you predict the y given x, you need to mention about the reliability and the accuracy of your estimation.